this video, let us focus on the concept of set in Python. Now, you will be using set when you want unique elements in your collection. Order is not a problem, and you want to do some operations like union, intersection, and so on with your application. So, whenever performance matters a lot, set is a preferred concept. But only thing you need to remember, there are no duplicates. These sets are exactly what we used to study during our school times. So they have no duplicates and they are unordered. So order will not be maintained, or whatever you want ordering, you'll have to convert it to into another data structure. But so let us try this out practically, understand how set works. As we have discussed, set in Python are denoted using the curly braces. So let us simply say numbers. And in my numbers, I am passing 1, 2, 3, 4, 5, 6, 7, and then I pass 5, 5, 5. Then I pass 7, 7, 7. Then I pass 9, 9, 9, and I pass 2 and 3. And when I print this type, I'll say numbers. What will happen here is you will see the duplicates value will be taken off. So if I say Python sets, oh, I have put it outside, so I'll just shift it properly first. Okay, set is added. So if I say Python base set py, see 1, 2, 3, 4, 5, 6, 7, 9, 9, and 9. So whatever values were repeated again and again are gone now. So this is how your set will work along here. Now, what are the other ways of defining, or how can we define sets? So first way is, yeah, let's use the constructor of set and pass any value we have. So I will say numbers, and if I say print type of first, and also if I print first, see this belongs to the class of set. So this is one way of defining a set in Python. Then other way is obviously quite straightforward, that you have got 1, 4, 5. This is how you define a set again. And but so I pass second, I pass second here, and this is my another set now. Now, how do we perform? So how do we perform various operations on set, like adding and removing? So for doing that, we'll simply just say, for example, second dot add, and here let's say I am adding 6, and I print second again after adding up here. So let's see what happens. So it is 1, 4, 5, and 6. Then if I want to remove something, so I have got second dot remove of 4, and I'm telling them what to be removed. And then after removing, if I say second, so it is 1, 4, and 6. Then we also have something called as discard. Yeah, we also have something called as discard. So let's see how will discard work now. See, we have done this. But what will happen if I try to remove after I have discarded the fourth element? Let's see what happens after this point now. So there is a basic difference between remove and discard. Remove, if the element exists, will delete it, and fine. But if the element does not exist, it will give you an error. In other case of discard, what it will do, if it is available, it will delete. If it is not there, it will not give you any error, it will straight away go ahead. So if you want to do some cleanup process and you don't know, like you have predicted some bad values, you can delete it using discard will be a good option. But you want to make sure that the thing should be removed, and if it is not there, you should be notified. The best option is you can go for remove function. The next operations what we are going to learn about is all about the operations we do in set. So we have got union where we take common elements between A and B plus all the uncommon elements. We do intersection where we only take common elements between A and B. Then we take difference. If we are taking difference between A and B, so I will take all the common values out plus any values of B, and it can be inverted as well. So symmetric difference is things we will which are there in A and B will be taken off. Only common values between A and B will be retained. So if I talk about those, so the operations are like what? Union. And for union, we have got functions called as union. Also, we have a pipe operation. So we can use a notation here. Then we have got intersection. So for intersection, we have got a function called as intersection, and it is also denoted using a ampersand symbol. Then we have got difference. The function name is difference, and we use a minus symbol, and we also have symmetric difference. So the method name is what? Symmetric underscore difference, uh, and the symbol is a caret symbol. So if I say, let's say first is 1, 2, 3, 4, 5, 6, and my second set, I'm just redefining those again. I'll start with 3, 4, 5, 6, 7, 8, 9. So if you see 1, 2, 3, so 3, 4, 5, 6 are common elements between both of the set here. Okay. So safe side, I'll just print it out here, and I'll say this is my first first then I will print the second value for second element. So this goes like second, and then I will simply do what here, start with the union operation. So I'll say print union, and what am I planning to do inside union operation? First is union underscore 1. I'll show you using the function here. So I've got first dot union second, and then I have got union underscore, let's say 2, which we'll do using notation. So it will be like first pipe second, and let's print it out. So print union hyphen 1 colon, and then I say union 1, then I say union 2, which will be my union 2 operation. Let's see the output. So here I have got first and second, and you see union 1, 2, 3, 4, 5, 6, 7, 8, 9 has been used. Next, let's do it for intersection. So here I will say inter underscore 1 is first dot intersection second, and inter underscore 2 is first ampersand second, which is same. And now I'll say print intersection 1, and I will just pass here inter 1, and here I will pass inter 2. So this is my intersection 1 and intersection 2. So if you see 3, 4, 5, 6 are common values between first and second. So as expected output, then let's try to find out for difference and symmetric difference. How will that work? So for this reason, I will say difference underscore 1 is equal to first dot difference of second. So it will give me those values which are only available in first. So if I say print difference 1, see 1 and 2 are only available in first. And if I try to replicate this in a different way now, so I'll say 2, and the symbol here is a bit different. So here I'll do what second minus the first, and this time I will make it difference underscore two. So only these elements are available in two, which are not there, like common value separated and your other value separated. These are only available here. Plus, we have got symmetric difference of one is first dot symmetric difference of second. And if I print now, so you will be able to see the output. Here it is 1 2 7 8 9. If you see 1 2 3 4 5 6 is common, so only 1 2 is taken from here, 7 8 9 is taken from here, and only those values are given. And the same thing can now be done using what symbol, that is first and second. So I'll just say first a caret symbol and second, and this time copy this and I get the same output. So this is all about set in Python. So thank you for watching this video. All these codes will be available on the Git repo. Please do subscribe to my channel and leave a comment like how did you like this video and any suggestions you have. Thank you.